Okay, this video is about empirical formulas. And what is an empirical formula? Well, an empirical formula is the simplest whole number ratio of the atoms in a compound. And so it's actually quite simple. So here we've got what we call a molecular formula, C6H6. So that is not the simplest whole number ratio of carbon to hydrogens. The simplest whole number ratio is 1 to 1. So this is its molecular formula, but the empirical formula, the simplified form of this, is CH. So this is how the molecule actually exists. This is benzene, C6H6, that's its molecular formula. But when we talk about empirical formula, we're just talking about the simplest whole number ratio of the atoms, and it's 1 carbon to 1 hydrogen, CH. All right, sometimes the molecular formula for a compound is the same as its empirical formula, but not always. So this is glucose, and here's its molecular formula, C6H12O6. Is that the simplest whole number ratio of the atoms in this molecule of glucose? The answer is no. The empirical formula for glucose would be CH2O. It's a 1 to 1 to 2 ratio. All right, now this video, we're going to learn how to determine empirical formulas of compounds using percent composition data, and we did this in a general chemistry class, and in AP we're going to add to it combustion analysis to determine the empirical formula. But first I think we need to review percent composition. So, usually when we say percent composition, unless it's stated something else, we mean percent composition by mass. And so let's just go ahead and do a problem. Let's go ahead and calculate the percent of iron in this ionic compound, iron 3 chloride. Now, a percent composition is just, for this particular case, the total mass of iron that's in this compound divided by the total molar mass of iron 3 chloride times 100. All right, so that should make sense. What's the percent by mass of iron? Well, put how much iron is it in divided by the total mass of the whole thing times 100. All right, let's give this a try. So here we've got the molar masses of iron and of chloride for the iron 3 chloride. So let's go ahead and calculate the molar mass of iron 3 chloride. So that is going to equal 55.85. We only have 1 iron. And we're going to have to add to it 3 times 35.45. And when we add that all together, we get, goodness gracious, 162, yes. 162.20 grams per mole. That's the total molar mass of iron 3 chloride. Now, if we want the percent iron in that compound, how many grams of iron are in that total mass of 162.20? Well, we only have 1 iron, so it's going to be 55.85 grams of iron divided by the total of everything, the iron and the 3 chlorides, times 100. And when we do that, and we're going to go to 4 significant digits, we get 34.43%. All right, so that's how you calculate percent composition. So now we're going to use percent composition numbers to come up with an empirical formula. We're going to go backwards.